Welcome to the world of data structures. Our today's topic is rotations in AVL tree insertion examples. Hi, this is your instructor Janice Shah. So let's begin with today's outline. Students, first we will talk about the outlines where we will take the understanding of the AVL tree insertion shortcuts and then take the example of AVL tree insertion. Okay. So students, here we have the first AVL tree insertion shortcut, that is, if you know, we in the last previous session we have seen these shortcuts. Okay, see, if you found a +2 +1 situation, if you found a +2 +1 situation, then your tree must be left heavy. So whenever you have a left heavy, then you need to give a right rotation. Fine. Students, next we have a -2 -1 situation, a -2 -1 situation where students, where your tree is a right heavy tree. So in such type of cases, students, you need to give a left rotation. So it is very much clear that if your tree is left heavy, then give right rotation. If your tree is right heavy, then give left rotation. Fine. Next we have, students, with us, that is the third case in which we are just doing like a +2 -1 situation. A +2 -1, a +2 -1, that means +2 -1, that means tree, right subtree of left subtree is heavy, right subtree of left subtree is heavy, then you need to give LR rotation, that is known as L-R, left rotation followed by right. And the last rotation, students, we have -2 +1 situation in which students, you need to apply RL rotation, that means right rotation followed by left rotation. Fine. Now let's start with the examples. So here we have our first example, that is construct AVL tree for the following values. Students, the values we have, that are 64, 1, 44, 26, 13, 110, 98 and 85 with us. Okay, so what you need to do is you just need to construct a AVL tree. Sir, how we can construct it? Okay, just take the value and put the values according to the binary search tree rules. Okay, after inserting the value, if your tree is violating a rule, then just apply the rotations according to the method of AVL tree. Fine. So let's begin the very first value, students. We have 64 with us. See, 64 with us. Okay. So 64 is the very first value. So 64 becomes our root node. Now just write down the balancing factor on node 64, that is 0. That is 0. Okay. So here we can say that, sir, the 64 is the very first value and the balancing factor is 0. Okay, so now students, 64 is successfully inserted because it is our very first value. Now students, the next value we have 1. Now tell me 1 is lesser than or greater than? Obviously 1 is lesser than 64. So students, we are inserting 1 on the left side of 64. So on the left side of the 64, students, we are going to insert 1 value. So here it is, 1 is inserted in the left side of 64. Okay, fine. So now insertion is successfully done. So after insertion, you need to write down balancing factor. So balancing factor for 1. Okay, so 1 is a leaf node, that's why balancing factor becomes 0. Now 64 on the left side of the 64, students, we have 1. On the right side of 64 we have 0 levels, that's why 1 minus 0 becomes +1. So balancing factor of 64 node is +1. Now next we have 44. So I'm going to insert 44. Students, tell me where we can insert 44. So the 44 is less than 64, so it must be go on the left side. then 44 is greater than 1, so it must be go on the right side. So 44 will be inserted on the right side of 64. So here it is, 44 is successfully inserted. Now, as my insertion is done, what I need to do is I just need to write down the balancing factor to check whether my tree is balanced or unbalanced. Fine. Now, the balancing factor of 44 is a leaf node, that's why it's 0. Now, balancing factor of node 1, 0, 1, node 1, that is, see, left side is 0, right side is 1, so it becomes 0 minus 1 minus 1. Okay. And on node 64, students, on node 64, we have plus 2. So, what happens over here? Plus 2. That means your node is violating the rules of AVL tree, because in AVL tree, we all know that balancing factor should not be greater than or equal to plus 2 or less than or equal to minus 2. Fine. So, what we are going to do is, here we are just applying our rules. Okay. So, this is the situation, plus 2 minus 1, plus 2 minus 1. That means here right subtree of left subtree is heavy. See, the right subtree of left subtree is heavy. So what I need to do is I just need to apply LR rotations over here. Why, sir, LR? Because if you can see the plus 2 minus 1 situation where the minus 1 that shows the right heavy and plus 2 shows the left heavy. So first we need to apply rotations on the violated node, that is plus 64, but 64 is violated just because of 0, 1. So we need to apply LR rotation, right rotation first, and left rotation first and then right rotation. Okay, so here it is, 1 is also violating the rule. Okay, so that's why we need to apply, students, LR rotations. Okay, so in LR rotation, what we need to do is first we need to apply left rotation on 1. So 44 will take the place of 1, 44 will take the place of 1, and 1 goes down. So here it is a L and right rotations over here, so that is known as LR rotation. First the 44 will take the place of 1, and then so the 64 becomes as it is, 64 becomes as it is, and then 44 in the place of 1, and 1 will go down. Okay, so what happens here, this left rotation is completed, left rotation is completed. Okay, so this is our new figure. But wait, should I need to write balancing factor over here? No, because my LR rotation is still pending. So what I need to do is I just need to apply right rotation on node 64, then and then my LR rotation is completed. Fine. So I am applying right rotation on 44. So for 64, okay, so 44 will take the place of 64. 64 goes down on the right side, and 0, 1 goes level up 1, and 0, 1 will go up level. So here it is, that there is a final rotation, students. We have 44 will take place of 64, then 64 will go down on the right side of 44, and 1 will become on the left side of the 44. Okay, so that is my final answer after inserting 44 and giving a LR rotation. So I get my answer. So what I need to do is I need to find out balancing factor again. So here all leaf node contains 0, 0, and the root node 44 is also contains 0. If you can see, students, the tree is balanced, but still my tree is binary search tree. You can easily say that this tree is binary search tree because all the lesser than values on the left side and greater than values will be on the right side. So it is also maintaining the binary search tree rules. Okay, fine. So now the next value, students, we have, that is 26. Now just check the 26 position. Okay, so 26 is less than 44, it must go on the left side. 26 is less than 1, no, it is greater than 1, so it must go on the right side of the 1. So here it is, insert 26. So I'm just inserting 26 on the right side of 1. Now just write down the balancing factor. All leaf node contains 0, 1 it contains minus 1 because it becomes right heavy, and the 44 becomes plus 1. So here after inserting 26, students, the tree is balanced or not? Just check it out. Tree is balanced or not? Yes, tree is balanced because there are no nodes, that is that violating the AVL tree rule. Fine. Okay, so let's start with another insertion operation. So in this same figure, if I'm going to insert the next value students, we have 13. Next value we have 13. So if I want to insert 13, then what happens? Let's check it out. 13 will be inserted on the left side of the 44. Then it is also less than 1, no, greater than 1. So it moved towards the right side of the 1, and less than 26, it moved towards the left side of 26. So here the 13 will be inserted on the left side of the 26. Now let's write balancing factor for all nodes. So here the balancing factors are, if you can see here the balancing factor are 0 0 on the leaf nodes. Now node 0 1, check the right portion of node 0 1. So right side of the 1 has 2 heights, that's why the node 1 contains balancing factor -2 and node 44 contains balancing factor +2. Now what happens over here, students? Here we have violation of 2 at the two different sides. Node 44 contains +2 and node 01 contains -2. So what we need to exactly do is, students, see, when your node contains +2 or -2 situation, then at that time you need to apply the AVL tree rule at the below of the hierarchy. Okay, so always start from the below of the hierarchy. We have 44, we have 1, but on the below of the hierarchy we have 1. So always try to first solve 1. 44 will automatically get solved out. Okay, let's see how. So here we have -2 on the 1. Okay, so it's a -2 + 1 situation. -2 + 1 situation for node 1. Fine. So what we need to do is, here we need to apply double rotation. Okay, so that is -2 + 1. -2 + 1, that means my bottom node becomes left heavy, upper node becomes right heavy. So on 26 I need to apply right rotation, and on 01 I need to apply left rotation. So it becomes RL rotation. So what I need to do is, here just I need to apply the RL rotation on the mentioned block only. So on this subtrace I am going to do is apply RL rotation. On 26 I need to apply right, and on 1 I need to apply left rotation. So here it is, that is RL rotation. So first on the left rotation, students, if you can say, on right rotation, students, then 13 will take the place of 26. 13 will take the place of 26. Okay, and then 26 will become on the right side of the 13. Fine. Now next we have, okay, see, 26 will go on the right side of the 13. So here is the answer. Okay, after the first rotation, then what we need to do is, we just need to apply left rotation. Okay, so left rotation will be applied on 1. So what happens after applying the left rotation? If we can say, the 44 64 remain as it is, 44 and 64 remains as it is. Okay, then 13 will take place of 1, 13 will take place of 1, and 1 will go on the left side of the 13, and 26 will become right side of the 13. Fine, here it is. If you can say, here it is. Okay, so after applying the final rotation, we again need to check the balancing factors. So here it is, balancing factor on all leaf node is 0, 13 is 0, 44 is +1. So after inserting 13, now my tree becomes balanced tree. Okay, so let's take the another value that we have 110 with us. So here it is. The next value we have 110. So just start comparison from the root node 44. 110 is greater than 44. Go on the right side. 110 is greater than 64. Go on the right side again. So 110 will be inserted on the right side of 64. So after insertion, don't take time, just do write balancing factor. I'm just writing balancing factor 0 on the all leaf nodes. Then 64 contains one child on the right side. That's why 64 contains -1. Okay, 13 contains 0 and 44 contains 0 also, because all the left subtree height and the right side tree height becomes equal for node say 44. Fine. Now Now taking this same tree, we'll move further with the value 98. So students, just insert 98. So 98 is greater than 44, so you have to move towards the right side, and then we found 64. So what to do with that? See, 94 is less than 64 or greater than? Yes, obviously it is greater than 64. So you need to move towards the right side of the 64. There we found 110. So what you need to do is you just need to place 98 on the left side of 110. So here it is. I'm just inserting 98 on the left side of 110. So okay, so after insertion, again check balancing factor. So all leaf node contains balancing factor 0, and then on 110 we have +1. Okay, 26 contains 0. Okay, then 64 contains, students, -2. 64 contains -2 because 64 has right subtree 2 levels and the left subtree 1 level. Okay, then 44 contains -1 also. So here, see, AVL tree rule is that not only the root node, the whole tree, all nodes must be AVL tree. That means here 64 is violating our rule. So we need to apply our rotations over there. Now just remember your shortcuts of AVL tree insertion, that which rotation we need to apply. Here we have -2 + 1 situation. See, here we have -2 + 1 situation. That's why, students, we need to apply RL rotation. Okay, so let's start with the first, the right rotation. Okay, that is on the node 110. Okay, so here it is. Let's start. 44, 26, 64 becomes as it is. 01 is also becomes as it is. Now the change will come on 110 and 98. So students, 98 will take the place of 110 and 110 go on the right side of the 98. Fine. So that is our first rotation. Okay. Now let's see. Next we have final rotation. So for final rotation, here we need to apply the left rotation on node 64. So what we need to do is 44, 26 and 01 becomes as it is. 44, 26 and 01 becomes as it is. Now 64 will go on the left side. Okay, and 98 will take the place of 64. 64 will go on the left side, and then 110 will on the right side of 98. So that is our final answer. Now let's write balancing factor. So all leaf node contains balancing factor 0, then 98 and 26 also 0, 44 is also 0. If you can check, this tree becomes our full binary tree. If you read definition of full binary tree, then this is our full binary tree. Fine. Now, is there any value left for the insertion? Yes, we have 85 with us. Okay, fine. So let's begin 85 insertion. So start from this is binary search tree, that is must be a AVL tree. Okay, so start from the root node. 85 is greater than 44, 85 is less than 98. Okay, and 85 is greater than 64. So it must be inserted on the right side of the 64. On the right side of 64. Now just write the balancing factor. All leaf node contains balancing factor 0. 98 contains the balancing factor of +1. 26 contains 0 and 44 contains -1. So that's it. Now check, is there any node that is violating our rules? No. That means this is our final answer. There are no rotations needed after insertion of 85. Okay, so what we are doing right now, students, we just did the AVL tree rotations after inserting each and every value. Whenever your tree getting unbalanced, you are applying rotations over there and make it balance. You are giving rotations over there and again make it balance tree. Okay, so always remember, this is a binary search tree. You are going to insert this value same as binary search tree, but remember, if after insertion your tree is become unbalanced, then apply rotations. We have 4 different rotations. There are left rotation, right rotation, LR rotation and RL rotation with us. Fine. So that's it for today's lecture. Thank you so much, students.